Good evening, Samhita.
Good evening, sir. Sir, I'm unable to access yesterday's recording.
You are?
Sir, yesterday's recording, I'm not able to access it, sir. Because I missed yesterday's class because I was writing JEE. So,
Okay.
like, is the video there?
I think so. My videos nowadays, recordings are not happening. I don't know what happened. Okay, that is only I'm calling to ma'am, but madam is not picking call. From last 3-4 days, classes are not recording.
Yes, sir.
Yeah, but I don't know what happened. So if you don't mind, can you wait just for 2 minutes? I'll call Char and I'll talk to him.
Okay, sir.
Ed. Hello, good evening, ma.
Good evening,
Good evening, all. Samhita, now only I asked the sir. Okay, sir is telling that there is no recordings at the session. Okay, so if you want to record any records means and at all, you had to request to the sir. If you raise the request means they'll provide the recording videos.
Okay, sir.
You got my point? Recordings are there, but that they're not placing in that one openly. So because of most of the students, they are regularly attending the classes. Okay, so due to the irregularity and they're depending upon that videos, they're watching the videos and at all. Okay, so that's why what SAR has done means he has done some technical changes. Okay, so who are absentees are there? If any reason it is there behind that one, behind the absent. Okay, so as for that one, they are providing videos personally to you. So whenever you want to see means we can't see the videos. Okay.
Yes, sir.
Now you got the clarity.
So if I request it right now, can I record the video?
Ma. So you want recording videos? After finishing of your class, just to text to the sir. Okay, admin department is there. Hope so. You can text in that one. They'll provide the video, whichever the classes you missed. That videos they'll provide to you.
Okay, sir.
Okay.
Yes, sir.
So now we are going to discuss about some new chapter. Okay. So we are going to discuss about some new chapter here. So already we finished the thermodynamics yesterday class here. Okay, what are the important concepts are there? Everything we discuss about the thermodynamics. Okay, now we are going to discuss about ionic equilibrium. Okay, so actually chemical equilibrium it is there. So chemical equilibrium is completely theoretical basis. Okay, chemical equilibrium is here completely theoretical basis. So first of all, what is mean by the equilibrium? Equilibrium. If I'll tell that for me, then we'll go for the further step. Only important concepts we are going to be revising. So what is mean by the equilibrium? What are the characteristic properties of the equilibrium? Okay, so first of all, so we have two types of the reactions. Is it right? Reversible reactions are there, irreversible reactions are there. Okay, reversible reactions, irreversible reactions are there. Okay, so what is mean by the reversible reaction? What is mean by the reversible reaction? What is mean by the reversible reaction, ma? What is mean by the reversible reaction?
Sir, when reactants turn into products and products turn into reactants.
Very good, ma'am. So when the reactants are converted into the products, products are converted into the reactants is called as a reversible reaction. Okay. Now, here what are the examples for that one means here? So 1 mole of the hydrogen gas is reacts with 1 mole of the iodine gas to form 2 moles of the hydrogen gas is called as a reversible reaction. Okay. So 1 mole of the hydrogen gas is react with 1 mole of the iodine gas to form as a hydrogen iodide. 2 moles of the hydrogen iodide is called as a reversible reaction. Generally, reversible reactions are carried out in a closed container or open container. Reversible reactions are takes place at closed container or open container, ma?
Closed.
Closed container. All reversible reactions are it takes place in a closed container. Okay, and irreversible reactions are there. Irreversible reaction. Sir, what is meant by the irreversible reactions means here? So reactions or reactants are converted into the products, but products cannot be converted into the reactant. What is the best example means calcium carbonate. Calcium carbonate is the solid. The calcium carbonate is heated at high temperature. If it is heated at a high temperature means forms as a calcium oxide is the solid substance and it forms as a carbon dioxide gas. Okay, now this reaction is the forward direction only. The reaction cannot be takes place in a backward direction. Sir, why the reaction is not takes place in a backward direction means because of the reaction is carried out. Irreversible reactions are carried out in open container. Okay, irreversible reactions are they carried out in a open container. Okay, so for that one we have different examples. Okay, that is also you can check it out here. First of all, I want to explain what is mean by the equilibrium. What is equilibrium? Okay, All of you must studied about the chemical kinetics. You must studied about chemical kinetics or not, ma? So what is meant by the chemical kinetics, ma? First of all, you tell me that. Chemical kinetics is, it explains the rate of reaction. Okay, under the chemical kinetics, we are going to study about the rate of reaction. Okay, sir, what is the rate of reactions means here? Rate of reaction is nothing but here, whether the reaction is going to be completed fastly, whether the reaction is going to be completed slowly. That part we are going to study under the chemical kinetics. Is that clear? Okay, so here rate we are talking. Rate means that change. What is meant by the rate? Change in concentration of the reactants along with the time is called as a rate only, na? Okay, change in concentration of the reactant along with the time is called as a rate of reaction. Is that clear? Is that clear? Simple. First, I'm writing as some chemical reaction. First, I'm going to write as some chemical reaction. Okay, sir, what is the chemical reaction I had taken means here? For example, calcium carbonate I had taken. Calcium carbonate I had taken. Initially, calcium carbonate is present in a solid form. Okay, so that I had taken in a closed container. Let us see, ma. That I had taken in a closed container. If I had taken a closed container, I'm heating continuously. If you heat means immediately it does not undergo the decomposition reaction. If you heat means immediately it undergoes the decomposition reaction. No, ma.
sir.
Slowly first it absorbs the heat energy, then it undergoes to the decomposition reaction. So here what happened whenever it starts the decomposition, when it starts the decomposition reaction, when it starts the decomposition reaction, it forms as a product. What is the product it forms? Calcium oxide is the product it's going to be formed, and it forms as a carbon dioxide gas. So what are the products it is going to be formed means here, slowly it forms as a calcium oxide and slowly it forms as a carbon dioxide gas. If the reaction is continuously happen for a long time, okay, after the long time, what about the quantity of the calcium carbonate? Quantity of the calcium carbonate is going to be decreases or increases?
Decreases.
Very good, Sita. Okay, so when the time is going to be increases mean the quantity of the calcium carbonate is going to be decreases. Sir, why it is decreases means decomposition reaction is going to be increases. That time reactants are converted into the products. Reactants are converted to the products along with the time only we can call as a change in reaction. Okay, that is only we can call as a change in reaction. For that one graphically also we are going to be represent. So that is also we are going to represent with here graphically. Okay, now how we are going to represent means I'm taking as a concentration of the reactant on the y-axis. Time I'm taking on the x-axis here. Okay, so time I'm taking the x-axis. Okay, concentration I'm taking on the y-axis. Okay, concentration I'm taking the y-axis. So concentration of the reactants I had taken. Which one I had taken, ma? Concentration of the reactant. So what I'm telling that if the time is going to be increases, concentration of the reactant is going to be decreases. Actually, this is the increasing of the concentration. For example, if the concentration of the reactant we are taking here, from here to, okay, slowly if the time is going to be increases. If the time is going to be increases means concentration of the reactant is going to be decreases. Okay, after completion of the reactant, you will get as a straight line. You will get as a straight line. This only we can write as here. Actually, normally we can write as here. This we are going to represent like this. Concentration of the reactant is going to be decreases along with the time. The concentration is going to be decreases means along with the time is we will get this kind of graph. Okay. Now, same one we are taking in a reverse reaction. We are taking in a reverse reaction. So reverse reaction is what happened here. Products are converted into the reactants. How the products are converted into the reactants means here. Let us see. In a reverse reaction, products are they become as a reactants. Okay, in a reversible reaction. Okay, so if the reactants are converted into the products, means that we can call it as a forward direction of the reaction. That we can call as a forward direction. Okay, if the backward direction, in a backward direction, products are converted into the reactants. Okay, now that is also we can take as a concentration of the products. Concentration of the product. Okay, if the time is going to be increases, formation of the product is going to be increases only, na? Sorry, the time is going to be increases means concentration of the reactant is going to be decreases. Initially we had seen Zero it is there. Initially, what it is there? Concentration of the product. At the time of initial reaction, any products are there?
No, sir.
Zero. So when the time is going to be increases, means product concentration is going to be increases only now. So increasing of the product along with the time, we are going to represent like this. Okay, increasing of the product. So along with the time, we are going to represent like this. Clear? So this it represent as a product. Sir, two reactions we can represent in only one graph. Two reactions we can represent in one graph also. Sir, how we are going to represent means here? Let us see. Here. Okay. So I am taking as a first reactant. This is the time. This is the time and concentration of the reactant. Time is going to be increases, means concentration of the reactant is going to be decreases. Time is going to be increases. Concentration of the product is going to be increases. Okay. Now, if you see means at one particular place, from particular place onwards, you got as a straight line. What is that straight line is going to be indicates means here there is no change in the concentration of the reactant and change in the concentration of the product. Okay. The particular place, there is no change in the concentration of the reactant and there is no change in the concentration of the product. That particular place only we can call it as a equilibrium. Okay, that is only we can call it as a equilibrium. Sir, what is mean by the equilibrium means here? The state at which molar concentration of the reactants is equal to molar concentration of the product is called as a equilibrium. Okay, so equilibrium can be represented oppositely double-headed arrow mark. Okay, equilibrium can be represented with here oppositely double-headed arrow mark. How we are going to represent the equilibrium? Equilibrium can be represented with here oppositely double-headed arrow mark. Actually, equilibrium can be exist in a closed container. Okay, equilibrium can be exist in a closed container. Okay, so existing of the equilibrium is dynamic in nature. Okay, existing of the equilibrium is dynamic in nature. Now we got the clarity. What is the equilibrium? What are the characteristics? And how we are going to identify the equilibrium means here based on how we are going to identify the equilibrium means equilibrium is going to be what are the characteristic properties of the equilibrium means equilibrium can be explained based on concentration. One is concentration, pressure, temperature, density and color. Density and color also. So all these properties are they explain the equilibrium. Okay, so all these properties are they exhibited that they explain the equilibrium. Okay, and in this one disadvantage is that catalyst, there is no effect of the catalyst. Okay, there is no effect of the catalyst on equilibrium. There is no effect of catalyst on equilibrium. Okay, and sir, not only catalyst. Okay, some inert gas also is at that different condition it is there. Okay, now these are the characteristic properties are there. So based on that one, again we have a two types of the equilibrium. Equilibrium is classified into two types. How many types it is there? Two types. What are the two types of the equilibrium we are having? So one is called as a physical equilibrium. Another one is called as a chemical equilibrium. Sir, what is the physical equilibrium? What is the physical equilibrium and what are the examples for the physical equilibrium? Tell me, any one of you. What is the physical equilibrium?
Changes of states of water.
Very good. Okay. So what is the physical equilibrium means? Let us see. Physical equilibrium. Physical equilibrium. Sir, what is the physical equilibrium means here? The equilibrium exists in between two different physical states is called as a physical equilibrium. Okay, the equilibrium exists in between two physical states is called as a physical equilibrium. Sir, what are the different types of the physical equilibrium we are having means here? One is solid liquid equilibrium. Solid liquid equilibrium. Okay, and another one is liquid gas equilibrium. Liquid gas equilibrium. Okay. And third one, solid gas equilibrium. Solid gas equilibrium. So all these are the different states of the physical states of the equilibrium. So where we can observe as a solid liquid equilibrium means here, what is the best example means we are taking as a ice cubes in a ice cubes plus water in a thermal flask. I'm taking, first of all, I had taken, let us see, ma. First, what is my question is to make you understand. Okay, everyone knows about the thermal flask, na? Thermodynamics also we got the thermal flask. So what is the main
Yes, sir.
importance of the thermal flask here? So thermal flask is one of the best example of the isolated system. And it is also one of the best example of the adiabatic process. So what is the adiabatic process? In adiabatic process, neither matter nor heat energy or exchanges with the surroundings is called as adiabatic process. Is that correct? In adiabatic process, change in Q energy, change in heat energy becomes as a zero. Okay, now what I'm taking, why I chosen the thermal flask means here, first in thermal flask, I had taken some water. I had taken some water, or bottle of the water I had taken one. Okay, in that one, remaining half I placed with the ice cubes. Remaining half I placed with the ice cube and close the container. After some time, what about the size of the ice cubes? Once it is exists the equilibrium, once it is exists the equilibrium means at equilibrium, what is the size of the ice cubes? Size of the ice cubes are going to be decreases, size of the ice cubes are going to be increases. Okay, so starting increases and decreases, or decreases or increases. Okay, or does not change. Options clearly once again I will give you here. Okay, initially decreases and increases, decreases, increases, first option. Second option, increases, decreases, second option. Okay, so no change, no change, or decreases. Size of the ice cubes are going to be decreases. Those are the options. Which one is the correct answer? At equilibrium,
Sir, no change?
no change. Very good, Sujita. Very good. Excellent answer, ma. Sir, here I have taken, sir. Why it is not going to be changed at equilibrium size of the ice cubes means first, water temperature it will be different. To maintain the water temperature equal, some ice cubes are going to be dissolved in a water. When they dissolve in a water means water temperature, ice cube temperature, it becomes as a normal. Okay, at one particular temperature, okay, they exist the equilibrium between the ice cubes and water. Whenever they exist the equilibrium between the ice cubes and water means here equal amount of the solid molecules are converted to the liquid. At the same time, equal number of liquid molecules are converted into the solid. It is a completely reversible process here. So whenever equilibrium is going to be exist, there is no change in the size of the ice cubes at equilibrium. If you want to check it out means happily you can check it at home also. Okay, it is a home experiment only. It is home experiment only. Okay, so but once you check it out the thermometer temperature and okay, and another one. Sir, what is the another example means here? Liquid gas equilibrium we are calling. Liquid gas equilibrium. Sir, what is meant by the liquid gas equilibrium? Where we are going to observe the liquid gas equilibrium means here cooking process. Cooking process. Have you seen the cooking process? Any one of you have habited to cook at home?
Yes, sir.
Sita only is telling that yes. Remaining, what about the remaining all? Niharika, Samhita, Samhita J. You don't have any habit to cook at home? General, I'm asking, ma. I'm not telling that I'm not forcing to cook at. So because of whenever you're cooking, some chemistry is related to cooking process also. That's why I'm asking. Okay. So liquid gas equilibrium, where we can observe as a liquid gas equilibrium means in cooking process. So we are taking some of the content, some matter in a water. Is it right? For example, you want to cook the rice. What we are doing here, we are taking as some rice grains in and we are placing in a water. Then we are placing on the stove. When you light the heat energy, when you supply the heat energy, so rice grains are slowly they convert into the rice now. Okay, in that one, actually, whenever the cooking process, we can't close the lid. Why? What is the reason? During the cooking process. Actually, nowadays we got as a all cookers, pressure cookers, and all we got. Is it right? But some people are there. They are cooking the rice in an open containers only. Okay. Okay. You forget. You don't know about that one. So, and one more question I'll ask. While having the lunch, breakfast, or dinner, okay, either yourself you are going to be served, otherwise your parents are going to be served to you. Samhita, Niharika, who's going to serve food to you? Either your parents, otherwise yourself.
Myself, sir.
Myself, Sita. Samhita, what about you?
Myself, sir.
Myself.
Okay. Now, so whenever you're going to serve yourself, if you're going to open the lid of the container means, okay. So while removal of the lid, some water drops are going to be fall into the food. That you observed or not?
Yes, sir.
Okay. So why, how you got as that water drops here? Actually, you didn't add any water. Na? After cooking, you didn't observe any water. Before cooking only, how you're going to observe as a water molecules and it all? From where you could have said that water molecules? Because of in hot condition, okay, water it will be in vapor formation. So whenever you're going to place the lid on the container, okay, on the surface of the container, if the temperature is going, that means air is going to be flows. When the air is going to be flows means here on the surface of the lid, it decreases the temperature. If it decreases the temperature means already you place the lid. That means inside water vapors are there. That means liquid is converted to the gas. That gas is, it undergoes to the condensation process. When it undergoes to the condensation process, that gas is converted to the liquid, it is placed bottom of the container. That's why whenever you're going to open the lid means immediately some water droplets are going to be fall into the food. Okay, so that is also we can observe based on here equilibrium. That is also we can observe here based on equilibrium. Now you got the clarity.
Yes, sir.
Okay, clear, right, ma? Clear. Next, solid gas equilibrium, ma. Solid gas equilibrium. Sir, what is the best example for the solid gas equilibrium? Means here we can take some camphor. Everyone knows the camphor, right now. So, and you take the camphor in a closed container, and you can take the camphor in a closed container, and you can maintain some particular temperature, ma. First of all, camphor is it undergoes to the sublimation process. Is it right? What is meant by the sublimation process? What is meant by the sublimation process?
Sir, conversion of the substance from solid to gas without going through the liquid form.
Ma? What, ma? The solid is converted into the gas without converting to the liquid form is called as a sublimation process. Okay. So what are the best example for the sublimable products? Camphor, naphthalene, benzoic acid. Okay. So all these are the examples. Iodine also is one of the example here. Okay. Now, first what we had taken means here we had taken as some camphor in a container. Okay. And we are maintaining the temperature is constant. I'm not changing the temperature. Okay. First of all, what happened? Some of the camphor is converted into the gas. Some of the camphor is converted into the gas. So because of gas is present in a closed container. After some time, there is an equilibrium in between the gas and solid. Okay, whenever the equilibrium is going to be exist means there is no chain. That means solid cannot be converted into the gaseous form. At the same time, so gas also cannot be converted into the solid form. Okay, that means equal amount of the gaseous molecules are converted to the solid and equal amount of the solids are converted to the gaseous molecules. We can't observe any difference. When we can't observe any difference means here, that is only we can call it as here equilibrium. And one more thing I'm telling them, saturated solutions generally we can call saturated solution. What is meant by the saturated solutions, ma? we have a three types of the solution: saturated solutions, unsaturated solutions, supersaturated solutions are there. What is mean by the saturated solution? What is mean by the saturated solution? Any one of you? Saturated solution means the no more solute is dissolved in the solvent is called as a saturated solution. No more solute is dissolved in the solvent is called as a saturated solution. So why means equal molecules of the solute is already distributed on the solvent. So if you add excess of sugar also, it won't be dissolved. Wherever the solute is, wherever the sugar is not dissolved in a water, means that particular point only we can call as a saturated solution. Okay, unsaturated means if you add sugar, means if it is dissolving in a water, means that we can call as unsaturated. Okay, and supersaturated, one condition is there. By increasing of the temperature, if the excess of sugar is dissolved in a water, is called as a supersaturated. So all these are the examples of here: physical equilibrium and chemical equilibrium and chemical equilibrium. Again, chemical equilibrium is nothing but here the equilibrium exists in a chemical reactions is called as here chemical equilibrium. The equilibrium is observed in a chemical reactions is called as a chemical equilibrium. Again, chemical equilibrium is classified into two types. Chemical equilibrium is classified into two types. What are the two types of the chemical equilibrium we are having? Means here homogeneous chemical equilibrium, homogeneous chemical equilibrium, and heterogeneous equilibrium. Heterogeneous equilibrium. Heterogeneous equilibrium. Sir, what is meant by the homogeneous equilibrium? Homogeneous equilibrium means, okay, in an equilibrium reaction, both the reactants and products are present in a same phase is called as a homogeneous. Sir, what is the example for the homogeneous equilibrium means here? For example, reactants I'm taking. 1 mole of the hydrogen gas is reacts with 1 mole of the iodine gas. Okay, it forms 2 moles of the hydrogen iodide gas. First of all, once check that ma product is gaseous form or solid or liquid? Product is gaseous form, gas, and reactants ma
Gaseous.
gases. Both the reactants and products are in a gaseous form, that we can call as a homogeneous. That we can call as a homogeneous reaction. Okay, and one to another one here. Hydrolysis of the ester. Okay, ester means CH3, COO, C2H5, liquid, it is the liquid, and solvent also we had taken as a liquid. So when the esters are, it undergoes to the hydrolysis, means it forms as a ethyl alcohol, C2H5, OH is the liquid, and acetic acid, CH3, COOH also liquid. Okay, the given reaction is homogeneous equilibrium or heterogeneous equilibrium?
Homogeneous.
Homogeneous. Sir, how you are telling that homogeneous means all reactants or products and products are present in a same phase? If all the reactants and products are present in a same phase, means that we can call as a homogeneous equilibrium. And heterogeneous equilibrium. So what is mean by the heterogeneous equilibrium means here, if the reactants and products are present in a different phase, means that we can call as a heterogeneous equilibrium. So what is the best example for the heterogeneous equilibrium means here? Here one is decomposition of the calcium carbonate. Actually, calcium carbonate is the solid, and if it is exists the equilibrium, and it has a calcium oxide plus carbon dioxide gas is going to be released as. Okay, now the given reaction is heterogeneous. Sir, how we are telling that heterogeneous means here reactant is the solid, products are solid, and gases are there. Two different phases are there. Okay, when the chemical reaction, in a chemical reaction, reactants and products are present in a two different phases, means that we can call as a heterogeneous equilibrium. Got it here? Okay, and we have one more here. Active mass one concept is, okay, according to the law of mass action. Law of mass action. Okay, according to the law of mass action, sir, we are going to define as an active mass. What is mean by the active mass? How we can define as an active mass? How we can define as a active mass. Active mass is nothing but it is the molar concentration. Active mass is nothing but here it is molar concentration. Sir, what is meant by the molar concentration? What is meant by the molarity? What is meant by the molarity? Mole per liter. Mole per liter. Sir, what are the units of the active mass means here? The units of the active mass is, okay, mole liter inverse. Mole liter inverse is the units of the active mass. Active mass can be represented within a square bracket. How we are going to represent the active mass? Active mass is can be represented with the square bracket. According to the law of mass action, okay, active mass of pure solids and liquids is equal to unity. Okay, according to the law active mass here. So according to the law of mass action, the active mass of the pure solids and liquids is equal to unity. Clear? Okay. Now here, so according to the law of mass action, the rate of reaction is directly proportional to molar concentration of the reactants. Okay, according to the law of mass action, so the molar rate of reaction is directly proportional to molar concentration of the reactants raised by their stoichiometric coefficients. So raised by their stoichiometric coefficient. So based on that one, shall we try one example here? So based on that one, we are going to derive the equilibrium constant formula also. Okay, equilibrium constant also formula also we are going to be derived. Okay, now let us see, sir. Sir, what this means here? Here, A moles of A is reacts with small moles of small b moles of the B. Okay, and it forms as a small c moles of the C is the products, and small d moles of the D is the products is going to be formed. Okay, in this one, what I told that here rate is directly proportional to molar concentration of the reactant. What are the concentration of the reactants are there? What are the reactants are there? A and B. A and B, how we can write this here? So A to the power of small a and B to the power of small b. So we have to remove the directly proportional. So to remove the directly proportional rate, we are writing as a rate is equal to Kf into A to the power of A and B to the power of B. I'm writing. So in this one, what is meant by the Kf means here? So rate constant in a forward direction of the reaction. Kf is nothing but rate constant in a forward direction of the reaction. F is nothing but here forward direction of the reaction. Forward direction of the reaction. And one more. So rate is, now you are taking as a backward direction. So rate is directly in backward direction, C and D are the reactants. That means rate is directly proportional to molar concentration of the C raised by C times and D to the power of D times. Okay, to simplify the directly proportional. So rate is equal to KB into, okay, C to the power of C and D to the power of D at equilibrium. Rate of forward direction of reaction is equal to rate of backward direction of the reaction. At equilibrium, rate of forward direction of the reaction is equal to rate of backward direction of the reaction. So according to that one, in place of rate of forward direction, what we can write Kf into molar concentration of the A to the power of A and B to the power of B is equal to Kb is equal to molar concentration of C to the power of C and D to the power of D. So if we bring all constant at one side and concentrations of the reactants at one side, that means we can write as a Kf by Kf by Kb. Kf by Kb is equal to molar concentration of C to the power of C and D to the power of D divided by, so molar concentration of A to the power of A and B to the power of B. So this only we can call as an equilibrium constant. That is only we can call as a equilibrium constant. So that is only Kc is equal to Kf by Kb. Kf by Kc. Sir, how we can define as the equilibrium constant means the state at which rate of forward direction, it is the ratio of rate of forward direction of the reaction by rate of backward direction of the reaction is called as a equilibrium constant. What is the another definition we can give means here? It is the ratio of products of molar concentration of the products by product of molar concentration of the reactants raised by their stoichiometric coefficients is called as a equilibrium constant. Okay, so Kc is, sir, Kc is nothing but it is the ratio of molar concentration of the products by molar concentration of the reactants raised by their stoichiometric coefficients is called as here equilibrium constant. Okay, sir, if you take the solutions means we wrote as a Kc. Okay, if you take as here solutions means we wrote as a Kc. Then if it is gases means what we can write? If you take gases means what we can write means here we are taking as a Kp, equilibrium constant at pressure. Okay, equilibrium constant pressure we are writing here. Sir, what is the relationship between Kp and Kc means Kp is equal to Kc into RT to the power of delta N. Sir, what is mean by the delta N? What is mean by delta N? Delta N is nothing but number of moles of the product of gases minus number of moles of the reactant. This one is applicable only for gases. Only for gases. Sir, same concept we already seen to explain the relationship between the delta H and delta U. Did you remember or not? Do you remember or not?
Yes, sir.
So we had seen some examples also that day. Okay, same examples we can apply here also. Here also we can explain the Kp and Kc relation also. Sir, when you will get as a Kp is greater than Kc, let us see, if delta N is equal to 0, if delta N is equal to 0 means Kp it becomes as a Kc. Okay, if delta N is equal to positive, so Kp is greater than Kc. If delta N is equal to negative, that Kp is less than Kc. Kp is less than Kc. Now you got the clarity?
Yes, sir.
So delta
Okay.
N is number of moles, right?
Which one, ma?
Delta
Delta N is number of moles. Change in number of moles.
Okay.
Number of moles of the products minus number of moles of the reactants. Got Samhita?
Yes, sir.
Okay. Clear? For this one, it is applicable only for gases. Clearly, I'm telling that don't apply for the solids and liquids. So one example I'll tell here. I want to give the clarity here. So because of calcium carbonate, CaCO3 is the solid. It undergoes to the decomposition reaction. It exists as an equilibrium. It forms as a calcium oxide plus carbon dioxide. So what is the delta N value in this one? What is the delta N value? Is the gas. What is the delta N value in a given chemical equation? Make it
1.
fast. Very good, one. 1. If delta N is equal to 1, then what about the Kp and Kc relation?
Sir, you said it is only applicable to gases.
Yes, ma'am. It is applicable to gases only. Correct only. So because of delta N is equal to number of moles of the products minus number of moles of the reactants. But in this one, if you see in the reaction, based on the reaction, means we have a product side, one gas it is there. That means 1 minus 0. Because of reactant side, there is no gases. So that's why 1 minus 0 I'm writing. 1 minus 0 means delta N value will get as a 1. If delta N value is a positive, positive means Kp is greater than Kc value. Got it? So
Yes, sir.
like that some questions are there. Okay, like that some questions are there. If you practice means you will get the clarity. Okay, Kp Kc relation also is there. Based on the Kp here, based on the Kc, we can explain either the given reaction is forward direction of the reaction or backward direction. That means his reaction is going to be completed or reaction is not completed. That is also we are going to be explaining. Sir, how we are going to be explaining means here, if the Kc values if Kc is equal to 10 power 3. If the Kc value is 10 power 3 means here greater than 10 power 3. Greater than 10 power 3 means it indicates the rate of reaction. It indicates the forward direction of the reaction. It indicates forward direction of the reactant. Forward direction of the reactant means here, so product's concentration is greater than that of the reactant. That indicates the reaction is going to be completed within a few minutes. That indicates the reaction is going to be completed in a few minutes. And if Kc value is less than 10 power minus 3, still reaction is at initial stage only. It indicates the reaction is at initial stage. Okay, if Kc values are in between 10 power minus 3 to 10 power 3, it is that. So that reactants and products are having considerable concentrations. Reactants and products are having considerable concentrations. Okay, actually why I had given this formula and it all means based on this formula we are having some of the numericals in the examination. Even in MSET level also, based on this relation only they're asking the question. Okay, and homogeneous equilibrium, heterogeneous, based on the homogeneous heterogeneous equilibrium also they're asking some of the questions also. Got it? Clear?
Yes, sir.
Right, Mark. So once you go through this one means you'll get some idea. Okay, then we'll continue in the next class. Thank you all.
Sir, what is reverse direction then? Kc value?
Reverse direction Kc value.
It should be greater than 10 power 3 for reverse reaction, for reverse.
For reversion greater than
10 power 3, sir. Given forward direction, what about in backward direction?
backward direction I had given here. Na? Let's see. Kc is less than 10 power minus 3. Ma. Kc less than 10 power minus 3. It represents as a backward direction here. Okay, it represents as a backward direction.
Okay, because you said it was the initial state.
Yeah, initial stage is nothing but here. Ma. Initial stage is nothing but actually you are asking backward direction. Backward direction means that the reactants are C and D. It is there. That time it is less than only na. As per you, if you take, you are talking based on the statement. Based on the statement means here in a backward direction means Kc is less than 10 power 3 in a backward direction. Samhita got the answer?
Okay, sir.
Okay, right.
10 power minus 3, the things the
So
reaction.
minus 3 is the thing that it indicates a concentration of the reactants. We are comparing the reactants here. Based on the concentration of the reactants and products, we can say that the given reaction is going to be completed or not completed. Got it?
Oh, yes, sir.
Positive value if you got means reaction is going to be completed. That means product concentration is you are getting as a more. So that is only delta n value you are getting as a positive. Na? If delta n is positive means what happened? Kc is greater na?
Oh, yes, sir.
Okay. So right now. So we'll continue tomorrow.
Thank you, sir.
So thank
Thank
you
you,
all.
sir.
Welcome.
Thank